Alright guys, so I've been getting a lot of emails about people asking, Boris, what are the derivatives of the inverse trig functions? So if you have y equals inverse sine of x, or y equals inverse cosine of x, or perhaps even y equals inverse tangent of x, how do you take the derivatives of those functions? Well, gee, I think that's a great question. So let me go ahead and try and answer that today. So that's going to be our focus. So for each of these cases, what is the derivative equal? And we're going to fill those in later. Before, I want to remind you guys what an inverse trig function actually is. So just recall, it's the opposite of a regular trig function. So if we say, for example, that the sine of pi over 2 is equal to 1, which it is, if you take the inverse sine of 1, you get pi over 2. So basically, you take the sine of some angle, and you get a ratio. Whereas with inverse trig, you take the inverse sine of a ratio, and your answer is an angle. So inverse sine of 1 is basically saying what angle, which we could just call theta, what angle theta has the sine of that angle equal to 1. That's what inverse sine represents. You're getting an angle for an answer instead of taking the sine of an angle. Okay, so that's just going ahead and what it is, basically, and talking about it. So these are opposites. So for example, if we say y equals the sine of x using the same relationship, well, then that means that x is the inverse sine of y. Okay, so they have that inverse relationship. The y and the x are switching. That's the key of inverses. So what we're going to do is we're going to try today to derive these formulas for inverse sine, inverse cosine, and inverse tangent. Okay. So we're going to derive a formula for y prime of your original function being inverse sine of x. Okay, so let's start with this. We're going to use implicit differentiation. So if y is inverse sine of x, I'm going to show you where the derivative formula comes from. You don't need to have this memorized, but if you forget it, it's a way you can kind of quickly come up with it. Okay, so if y equals inverse sine of x, that means that x equals inverse sine of y. Okay, now, x equals sine of y, geez. So then what we're going to do is do implicit differentiation. So once we've written it like this, we're going to do implicit differentiation to find a derivative. So we get 1 equals the cosine of y times dy dx. So that means that my dy dx is equal to 1 divided by cosine of y. Now, this might be a little frustrating, right? Because we had a function of x, we'd like our derivative to be in terms of x. So what we're going to do is we want to be able to write cosine of y in terms of x. So the way we do this is a trick you'll see a couple times in your math career. You're going to draw a right triangle. Okay. So what do we know? We know that the sine of the angle y is equal to x, which you could write as a fraction as x over 1. Well, thinking about SOHCAHTOA, that means that sine is opposite over hypotenuse. So that's saying that if we have a right triangle, this is our angle y, the opposite over hypotenuse is x over 1. Okay, so if I want to find the cosine of this angle, I need to find the missing side. So I'm going to find the other side and then use that to find cosine of y. Okay, so this other side, I don't know, let's just call it a. So a squared plus x squared equals 1. So a is the square root of 1 minus x squared. Okay, so that's this missing side. So if you want to find the cosine of this angle, it's adjacent over hypotenuse. So that's just root 1 minus x squared over 1. Okay, now that, in fact, is what we're going to plug in here to my derivative, telling us that the derivative of inverse sine is 1 over root 1 minus x squared. Okay, and that's the formula. I think if I would have asked you, like, what's the derivative of inverse sine, none of you would have guessed 1 over root 1 minus x squared, but it is. If you didn't fully understand this process, that's totally fine. I know the triangle thing is a little weird. The important part is this comes from implicit differentiation. And this is a formula you'll need to know for the AP test or be able to come up with. So let's write that down. So the derivative of inverse sine is 1 over root 1 minus x squared. You could do this exact same thing, basically, to take the derivative of inverse cosine, and it's the exact same thing, it just has a minus sign on top. Okay, so the other thing is, what might be the derivative of inverse tangent? Okay, so again, let's derive the formula for inverse tangent of x. Oops. So y equals the inverse tangent of x. And we're going to come up with what the derivative is equal to. So again, let's go x equals tangent y, like take the tangent of both sides, or just kind of rewrite that. That just means, right, if y is the inverse tangent of x, then the tangent of y gives you x. That's how inverse tangent is defined. So then if we take a derivative here, we get secant squared of y times dy dx equals 1. So my dy dx is equal to 1 over secant squared of y. Now you might remember that secant of anything is just 1 over the cosine of that thing, flips it. So this is actually just cosine squared of y. So again, we have to ask ourselves, what does cosine of y equal in terms of x? So let's draw a little picture. So the tangent of that angle y is equal to x over 1. Tangent is opposite over adjacent. So what that means then, if you draw like a right triangle, the tangent of this angle y, the opposite over adjacent, is 1. So keeping in mind, again, the Pythagorean theorem, what is this hypotenuse? So r squared equals 1 squared plus x squared, so that r is the square root of 1 plus x squared. Okay, so that's the other side, using Pythagorean theorem. Now, when I want to find the cosine of that angle, again, cosine is adjacent over hypotenuse. So that tells you that the cosine of y is 1 over root 1 plus x squared. And then if I just take that and square it, that tells us, if I like square this fraction, it tells us the derivative of inverse tangent is 1 over 1 plus x squared. This is square and the square cancel. Okay, so that is the formula for the derivative of inverse tangent. So let's put that up here. Okay, these are the 3 key formulas for today, and that is the crucial part of your homework. Most of your homework today is just going to be using the chain rule or using the product rule on these. So let me just give a couple examples of what that might look like. For example, suppose I ask you to differentiate. Say f of x equals inverse sine of 3x. Okay, so let's take a look at this. So what we have here, we know that if we have the inverse sine of x, we know that derivative is 1 over root 1 minus x squared. So if I'm taking the derivative here, well, here's how the chain rule works, right? We're going to plug in the 3x, and then we multiply by the chain, by the derivative of 3x, we multiply by 3. So we're going to plug in the 3x here. So we're going to have 1 over root 1 minus 3x squared. And then we'll multiply by the derivative of 3x, so we just multiply by 3. If you want to clean this up into 3 over square root 1 minus 9x squared, that's totally fine, but you don't have to. Okay, one other example you might see, here's kind of a different notation. Suppose I asked you to differentiate, say f of x equals 4 times inverse tangent, or sorry, not inverse tangent. The notation I wanted to use was arctangent of x to the third. Now, one thing I did want to tell you guys, this is just a notation thing. The arctangent of x is just another way to write inverse tangent of x. They mean the exact same thing. The arcsine of x is the exact same thing as the inverse sine of x. Don't be thrown off when you see that notation. It's literally identical. Okay, so again, we'll start with the derivative for inverse tangent. So if we have inverse tangent of x, I'm a good student, so I've already memorized that it's 1 over 1 plus x squared. So if I take my derivative here, the 4 stays in front. The derivative of arctangent, or inverse tangent, is 1 over 1 plus x squared. But because of the chain rule, it's 1 over 1 plus x cubed squared. And then by the chain rule, I multiply by the derivative of x cubed, which is 3x squared. So I might clean this up to be 12x squared divided by 1 plus x cubed squared is x to the 6th power. Okay, so that's how you work with these derivatives. Again, you don't necessarily need to know where they come from. I did want to show you guys that just for, the sake of rigor. But the important part is using them and applying them, chain rule, product rule, and stuff. Okay, thanks for watching. Bring questions if you got them, and I'll see you soon.